Our next demonstration shows using asymmetric cryptography with GDC. The first step is to log into GDC itself. Here we're doing GD Cloud Auth login. This pops up the browser. We log in with our application operator user. Once the user's logged in, we're going to specify some environment variables. First one is the account that we're using. Next is the cluster that we connect to. Here we're connecting to the organization admin cluster. Specifying a kubeconfig environment variable, and then getting the Kubernetes token. Now that we have the Kubernetes token, I'm going to list out the projects within our organization. The organization that we're going to be using is backend. So I'm setting a project variable to backend. Next is to view the roles that are assigned to my account. We're specifying the project that we're checking, the account name, and then we're doing a search specifically for the roles that have KMS in them. The first three that we see here are the ones that we're interested in. We're interested in KMS admin, which allows us to manage and delete keys. Next is KMS creator, which allows us to create keys, and then is KMS developer, and developer allows us to use the keys. Next, we're setting an environment variable called GDC_public key. So that's going to be the name of the key that we create. And then here we're actually using a Kubernetes API call. We're going to create a signing key. We're going to name it with our public key name. We're attaching it to the project that we specified, and then we're using a SHA-384 algorithm. The next command looks for our signing key that we had just created within the GDC project and checks its status. Here we see that the key is ready for use. Another environment variable is being set here. This will be the public key that gets exported from GDC. This kube control command gets our signing key with our public key name from our project, puts the output to JSON, does a JSON query looking for a status public key. It then takes that output, base64 decodes it, and saves it to this file name. So that is exporting our public key. Setting another environment variable to a plain text file. And next an environment variable which will create a signature file, or this is what the signature file will be named when it gets output. This command uses the GD Cloud asymmetric signing call, specifying our project, our signing key, our plaintext input file, and then the output signature file for the signed portion. Next, we're using the OpenSSL command, using the digest function to validate using our public key, SHA-384 algorithm, with the signature file that we had just created, and then our plaintext file. It should come back with verified. To see what would happen if the file had been tampered with, I'm going to make one little change, inserting a period into the plaintext file. Now I'm going to rerun the validation with the OpenSSL, and we see that the verification failed. Because that file has been changed, it no longer matches the signature. To delete a key, use kube control, specifying our Kubernetes configuration file with the delete command, specifying the type of key, and then the name of our key and the name of the project. See, the key was deleted, and then to validate that, we can use the kube control command specifying to get signing keys in our GDC project namespace. And here that we see there are no keys currently in that namespace.